Okay. Alrighty. Welcome everybody to Cloud Native London / Kubernetes 10th birthday party. Woohoo! Yeah. Oh, I need to resume my share. We are a strong, open, diverse developer community around the cloud native platform and technologies based in London. This is now the 7th year that I've been running this. So we started not at the beginning of Kubernetes, but not long after. I'm your host for the evening. My name is Cheryl. You can find me online at oicheryl.com. I'm a senior director at ARM. Tonight we have 3 talks for you. The first talk is going to be from free kicks to Git commits from Steve. Then 7:15 we have platform and DevOps practices from Stephen. Then we're going to take a 15-minute break at 7:45. Come back in here for 8 o'clock for cost-conscious cloud-native engineering. Then 8:30 we're going to wrap up and we're going to go to the conductor hub, which is just down the elevator straight outside on the left. It's 1 minute for more talks and more drinks afterwards. Because it is the 10th birthday party, we're doing a special raffle. Whereabouts is yeah. Come and do your explain what this is. Do it now. Just explain.
Oh yeah. So basically just to mark the 10th anniversary, 10th birthday of Kubernetes, what we thought is we do a little raffle. So everyone or most people should have a raffle ticket. If you don't, we still have some. We can sort those out later on. Yeah. We have 2 prizes, same prize. We have 2 lovely bottles of 10-year age whiskey to give away. And obviously the most important thing is the Kubernetes bags and the balloons as well, equally as good. So we'll be doing the draw at the break. Yeah, thanks very much.
Thank you. Okay, so now I'd like to get to know a little bit about you. So please grab your phones, go to this link or go to that QR code. We're going to do some live polling and ask 2 questions about you and 3 questions about how you use cloud native that were submitted by our speakers tonight. You don't have to download anything. You'll just open this thing in your browser. Okay. So, I see people have already gotten started. So is this your first time at Cloud Native London? So you'll see a yes and a no answers. So you just tap whichever one it is. Looks like people are already figuring out sort of no, 2/3 no, 1/3 yes, first timers. We're also live streaming this to YouTube and to Twitch. Hello, folks at home. So there might be some people who are answering this from home as well. But this is great. I love that there's a lot of first timers here as well. So if this is your first time, thank you so much for showing up, for coming out and sharing, spending your evening with us. What's your job title? So just pick whatever's closest. You've got architect, application developer, backend developer, engineering manager, DevOps / platform engineer, security engineer, or anything else. Oh, looks like the DevOps platform engineers are pulling way ahead tonight. 50%, handful of architects, handful of backend developers also joining in. But definitely a DevOps evening, which is wonderful. Okay, first question from the speaker. What is the primary reason some organizations choose not to use Kubernetes in their production environments? So your answers are complexity and a steep learning curve, lack of support for multi-cloud environments, limited scalability, or insufficient security features. So lots of people starting to answer those now. Complexities, definitely way ahead. No one's saying scalability yet. A couple of people are saying lack of support for multi-cloud. and security. Where is Steve? Steve. So this question came from Steve. Is this what you expected? This 80%? It is? Okay, so this is the right answer, quote unquote right answer. Yeah. Yeah, CNCF just released a survey which also agrees with this, that complexity is one of the biggest challenges. Next question. Do you work in a team that contributes to a platform? So yes, or I work in a team but don't contribute to a platform, or no, I don't work in a team. Interesting. So yes, lots of people saying yes, they work in a team. 20% people saying they don't work in a team, which I guess that seems high, but where's Stephen? Stephen, yes. Yeah, what do you think? Is this what you expected with this question? Okay, well, wonderful. So Stephen just said, I think there are more platform engineers here than I realized. Good stuff. Next question. How often do you get unexpected charges from your cloud providers? Your options are all the time, very often, occasionally, or never.
You want the answer about that?
Yeah. It's all the time. Alex. Here we go. Yeah, so people are saying, well, most people are saying at least occasionally, if not more. Is that what you've seen as well?
Mine, what I expected. Of course, there's the unknown unexpected charges as well, right? When there is an unexpected charge and you don't even know about it. So
yeah,
couldn't answer. But yeah.
Yeah.
I'll type in.
All right, fantastic. Thank you very much, everyone, for contributing to the live polling tonight. Keep this up on your phones because we're going to use this for Q&A as well. And oh, I need a selfie for social media. So hold on, everybody. I'm gonna do this. Maybe I'll do a video where everyone say like happy 10th birthday, Kubernetes. Okay, happy birthday, Kubernetes. Yeah. Okay, I'll do a video first and then we can do some photos. Okay. So we'll go 3, 2, 1. Happy birthday, Kubernetes. Okay, everybody wave. Right. 3, 2, 1. Okay, we're gonna do that one more time. Yes, exactly. Okay. 3, 2, 1. Okay, and I'll just do a selfie as well. Okay, wait. Thank you, everyone, for playing along with me. If you want to come and speak on here, or you want to sponsor, or you want to promote your own event, go to cloudnativelund.com. We're now booking speaking slots for next year, so plan ahead. You don't have to give your talk title right away. You can just book a slot, and then we'll ask you 2 weeks beforehand for your talk details. And that's it. I'm going to hand over to Steve now. So please, round of applause to welcome our first speaker, Steve.
I'm going to use this, I think. Is this working? Are we good? Okay. Oh, it's kicked me out the Zoom.
Cheryl, I think because you're live speaking, I can't share my screen. Okay, I think we're good. Cool. So yeah, my name's Steve Wade. I'm an independent cloud native consultant and trainer. And I'm going to talk to you about my journey from playing football to kind of getting on stage talking about what I'm doing now and all of the lessons before that I've gone through. I want to start off with the fact that I support Man United, like this Man United, not this terrible Man United. We'll just kind of gloss over that. And for people that know me, they're probably like used to me tweeting about kind of Kubernetes and GitOps, and then they see these kind of random tweets here about formations that Man United are playing. And hopefully this is going to kind of dispel some of the myths of why I just randomly tweet this gobbledygook online. So I want to prefix this with there's absolutely no YAML or no JSON whatsoever. It's very minimal slides. It's mostly about a journey. You're not going to have to worry about if my indentation is correct or anything like that. So what we're going to talk about, well, I'm going to start you off with like a story. We're going to talk lessons from the field. We're going to start from the football field and how that translates its way across to technology and the business side of things. And then we're going to talk about how I went and embraced a new field. So there was a certain incident that happened when I was 18 years old and I had to kind of pivot to a new type of field. And we're going to talk about the journey that I went on to perform that. Then we're going to talk about how I actually discovered Kubernetes, because I think it's an interesting story. And then we'll talk a little bit about some key takeaways. So I'm going to keep up with Cheryl's interactive participation. So if you scan this QR code here, you should get the first question. And the first question should be, what is the most important trait of being a good member of a team? Yeah. So there's a couple of obvious ones coming in here. The one that I'm specifically looking for, I haven't yet seen. But what I'm going to do at the end of the talk is I'm going to explain the one that I think is the most important and the one that kind of goes a little bit missing. So let's kind of start with my story. So at the age of 4 years old, I was hired by an academy from a professional football club that no longer plays in the Premier League anymore. How they can scout someone at the age of 4 years old, I genuinely have no idea, but it happened. So I was like any kid, right, living the dream. I thought I was going to be Cristiano Ronaldo or David Beckham. I was going to be on about £1 million a week, and all my troubles were just going to be like, what car am I going to buy next? I was the cool kid at school, right? Everyone was like, oh, can you come and play for the school football team? You've got plenty of money rolling in. Can you like buy me the newest set of trainers or anything like that? But then when I was 18, this happened. So I got a really seriously bad knee injury, like pretty squeamish. I could actually spin this kneecap both ways around my leg. I blew my ACL, I blew my medial and lateral ligaments. And this was me for 18 months. I couldn't weight bear, I couldn't do anything. Then this happened. Right, I got seriously depressed. My whole entire life, everything that I'd spent the last 14 years going to the gym, playing football, making new friends, it vanished. Right, I felt like my life was over. My only true passion was playing football. I had nothing else. I didn't know what I was going to do. What I needed to do is I needed to refocus. So all of the time that I spent in the gym, waking up at 6 a.m., going and doing a swim, coming back, having breakfast, then going to school, and I was doing my homework on the way to school because I couldn't do it afterwards because I had training. I had to refocus that time and put it somewhere else. Because if I didn't put it somewhere else, I didn't know what I was going to do, right? When I left the football team, that was it. It was over. Contract ripped up. They just said, move on next. You're no longer useful to us. And there's a very good documentary on BBC about that whole situation of what happens when they let people go and kind of the depression and spiraling out of control that can happen. So what were the main lessons that I learned from actually playing football? Well, there's some obvious ones, right? There's teamwork. So a football team doesn't succeed unless all of the constituent pieces of that puzzle work together to achieve a common goal. And I didn't play striker, I actually played midfield. But the striker is the one that always gets the glory, right? Who's your favorite player? Everyone says Mbappe, everyone says Haaland because they score all the goals, right? But he or she doesn't score the goal unless all of the constituent passes that make it up to the striker actually happen. And it's exactly the same in technology as well, right? It's not just the people that are developing the code that are building the features that are the ones that are succeeding when the product gets launched. There's a whole plethora of people within the organization that is responsible for making that product launch. Then we've got strategic planning. So there's obviously strategies that have to go into play. We can talk about the first half versus the second half. And how does that kind of translate into the tech industry? Well, that's really about kind of agile sprint planning. What are we going to do this sprint and what are we going to do next sprint? So if we take the second half as like the kind of next 2 weeks, what are we going to do in the first 2 weeks that kind of sets us up for success in the following 2 weeks? It's very similar with football in that regards as well. Then we've got adaptability, right? So footballers, you have to adapt quickly. 1 minute you're playing midfield, the next minute you're playing defense, the next minute you're on the substitute bench for 4 weeks and you're not playing, right? And you have to be able to adapt to those different situations. Some of those are the situations that you don't necessarily want to be in, right? A prime example of that in tech is like no one really wants to be doing technical debt, but we have to kind of do it, right? They want to be doing all the fancy, nice, interesting pieces of work. But sometimes we have to do those pieces of work that we don't want to be doing because it contributes and allows us as a team to be more effective and more efficient. Then we have kind of performing under pressure. So this is not me, but this is a situation where there was going to be a penalty shootout. And essentially, if they won this, they would go through to the final. Kind of spoiler, they'd never really made it to the final because they got to the penalty shootout and they couldn't perform under pressure. They missed, I think, every one of the 5 penalties that they took. They missed all of them. Right. And what does this translate into in a technical aspect is really about how do we deal with incident response? Right. And a lot of incident responses, like we all just scramble around like headless chickens and try and work out what we're going to do in an incident. But actually, if we plan for failure, we can perform well under pressure. That may be writing like run books for how we're going to deal with certain situations. It may just be making sure that we have the right people in the room at the right time. Resilience and perseverance, right? We have to do this both, from a professional standpoint as a professional sportsman, we get injured. Right, there's a reason why a football team's not made up of 11 players, it's made up of 23, right? Because people get injured and people have setbacks and challenges. And if we translate that to engineering, that's really about downtime, right? And debugging and how we need to persevere when we hit this problem, right? We had a problem on stage earlier when Stephen was trying to get his slides to show and he got his slides working and not his notes, right? And we persevered and we somehow managed to get it working. I still don't know actually how we did it, but we persevered and managed to make it work. And we need to come up with innovative solutions, right? Sometimes the position that I played, which is midfield, sometimes I have to play in defense. I don't want to be in that position, but that's where I can make the most use and most benefit to the team. And we have to do that in engineering as well. Some obvious ones as well is leadership. He's a terrible captain, by the way, Maguire. Hopefully we get rid of him. Rice is actually way better. Come and talk to me afterwards about how much I hate Maguire. But this is really about tech leads, right? And there's normally one tech lead in the team, but there's one captain on the football pitch. But what we got taught is there needs to be multiple leaders in a dressing room, right? They need to drive the standards. They need to drive the culture. Another reason why Man United are terrible is because they don't have any of these. They just have him, apparently, and Bruno. So their job is to instill a culture of success, right? But it's also about how do they mentor others, right? Professional sportsmen need to mentor the people in the reserve team and the people on the substitute bench. And they need to show a pathway to get to the first team, right? If there's no pathway to the first team, then these people and players are just going to leave. And it's very similar in technology and in business. If there's no pathway for you to succeed as a senior member of the team, then you're going to look elsewhere. So what are the pathways and how can we mentor young people? I think is a really important thing that we need to consider and think about. I don't know why I kept having him, but anyway. Mental stamina is another one, right? As an example, I got injured, I think, from the age of 4 to 18. I think it was 23 times I counted on the train when I was on my way in here. And it's a long, enduring career, right? And if you're lucky and you're really good, you start at 16 and you kind of tail off at like 30 to 34. So there's mental stamina during that career, but there's also another set of mental stamina that you need to have post that career. So what are you going to do and how are you going to set yourself up for success? But if we take that from a technical standpoint, that's kind of like hackathons, or like how are we going to do product launches, and what mental stamina are we going to need to actually make the successful product launch in insert random set of time here. Communication, I can talk enough about his type of communication that he does regularly. But effective communication is key, right? On the playing field, one of the things that we tried to do is we actually tried to play football in silence. And if any of you have tried to do that, it's absolutely impossible, right? And it's like the same with business. If you do business in silence and you've got silos that don't talk to each other, then we're not going to succeed as an organization and we're not going to be able to release that product. And it's really about that interdepartmental communication. So how do I get HR to make sure that they're getting the right people through the funnel for me to build out my platform team that I'm currently working in? And then how do we do documentation and reporting, right? So how do I make sure that application or product team A's API is well documented, and that conversation for the consumer of that API, they're having regular conversations, right? Too many times I've seen these, just like go to the documentation or the documentation will tell you everything. But we need to get into this state where we actually communicate with each other and are not scared to open up and talk. To me, this is the biggest one, right? Empathy is the most important thing that I learned as a footballer. And it's something that I carry very close to my heart. So what do I mean by empathy? The first thing is to understand roles, right? What is the role of each individual in the team? What are they responsible for? What are they not responsible for? Think about that as me being captain of the football team, and I have to work out and explain to people what the roles of the people are, that the substitutes, the ones that come on for 20 minutes, 10 minutes at the end of the game, and they see all of their friends playing, 85, 90 minutes constantly, week in, week out. And then it's about the reserve players, right? What are their roles and how do they see themselves to have a pathway to get to the first team? And some of these things may be less visible to others, but it's really about making sure that it's visible and obvious and well-defined what these roles are within an organization. And again, to the workplace, it's really about, inclusive leadership. So allowing people that aren't the most vocal in the team to actually have a voice, to have an opinion and have a say about something, right? And there's too many times, and I've been guilty of this as well, we sit in rooms and we discuss how we're going to implement something, and there's the seniority bias, right? Which is, I've done this before, I know exactly how we should do this like this. But actually there could be a younger member of the team that actually has a completely revolutionary way of doing it that would halve the amount of time. But if we don't give them the space in which to have those conversations and open their mouth and feel like they're not going to get shouted at, then we're not really setting a culture that a company or an organization wants to have. The other one is recognizing contributions, right? So every team member, regardless of their position, needs to feel valued. We go to the football team, we think about the reserves, we think about the substitutes. And we need to acknowledge and kind of foster the fact that everyone's contribution is valid and it's positive, even in an incident, right? We're going to learn something. Maybe somebody made a mistake. That's okay. But how can we move that forward and make sure that we don't make that mistake again? So that's kind of enough about football. If you're not a football fan, the football's over. So now roll forward. I'm now kind of, I think like 10 or 11. My knee injury happened at 18, but I want to kind of roll back a couple of years. So when I was 14, I saw one of these and it kind of blew my mind. I didn't really know what was going on because I never spent any time in front of a computer. I was always in a swimming pool, in the gym, on the way to school, on the way to football training or back again. I never really got time to sit down and look at a computer screen. It was mostly a television because I was watching someone else analyze what we were doing as a footballer. So what I'm interested in is, what is your first computer that you ever used? ZX Spectrum it's a good one. I was expecting some MacBook Pros. Okay, so I saw this computer and it kind of it fascinated me, right? I didn't really know what was going on, and I saw something like this. Right. And my dad was in IT and he was an IT professional. And I just saw something like this and I was like, kind of, what on earth am I reading? This doesn't look anything like English. Like I'm at school and I'm seeing spaces between words, and now you're kind of concatenating words into camel case, and why your method names like off the screen, like wrapped multiple times. And what I realized is actually he's doing relatively well for himself. We're going on multiple holidays a year. Maybe this is the kind of direction of travel that I want to go in. I didn't want to do commentating. I didn't want to be on the TV trying to convince everybody that I knew absolutely everything about football, because I clearly didn't. And I needed a passion to refocus into. And this was the passion that I wanted to go with. I thought, if I put all of my heart and soul into this, something beneficial will come out of it. So I spent all my time getting my dad to tell me and teach me kind of if loops and while loops and for loops and kind of all the obvious interesting things like that. And then I just did relentless studying, right? I just studied everything I thought was interesting to me. That was from all the way to learning what VLANs were in networking, all the way up to kind of learning about PHP, which turned out to be a bad decision. I probably should have learned a different programming language. But anyway, I spent time studying that. And this is a quote that stuck with me for many years when I played football, and even more now, which is hard work beats talent when talent doesn't work hard, right? I didn't have talent in IT. I didn't really know what I was doing, right? But I knew that if I worked hard at it and I spent enough time dedicating myself to it, something would happen. I don't know what that something was at the time, but I knew that if I spent the time doing it, I was going to achieve something. There wasn't a quick initial learning curve that I had, but it was really about, and what I found interesting was kind of solving problems that I had no idea how I was going to get to the answer of them or the bottom of them. Then kind of roll forward a little bit. How did I kind of come on to discovering Kubernetes? So I was on site at a client. They had a number of BAU applications. There was about 15 of them. The kind of application team was about 5 people. This was like tech debt on steroids, but they have a dedicated team for doing the tech debt. And we couldn't install multiple versions of the same dependency because you couldn't have multiple versions on the same machine. Everything was taking forever. Fixes that should have taken 1 day were taking 5 to 10 days because we had to uninstall and reinstall everything. And then a colleague of mine, or a friend of mine, sorry, worked for a startup, and that startup got acquired by Docker. And he said, look, just stop doing everything you're currently doing. Just go with containers. It's going to revolutionize the world. And like stupid, naive me kind of just thought, okay, let's do it. What's the worst thing can happen? So I'm running Docker Swarm in production, for better or for worse. And then I got to this port conflict problem and I couldn't get past it. And I was really, really struggling. So I remember writing a tweet randomly I couldn't find it, which said something along the lines of, I can explain Docker Swarm to non-technical people, but I tried to understand Kubernetes and I tried to explain it, and I just have literally no idea what I'm doing. Can somebody help me? And I remember Kelsey actually replied to me and he said, oh, I'll jump on a Google Meet with you and I'll talk to you for like 15, 20 minutes, half an hour, whatever, and I'll kind of explain it to you. And he explained it to me as a bowl of fruit or multiple bowls of fruit. And you as a person pick your hand and put your hand in and decide whether you want the apple next to the banana or the banana next to the pear. And it just kind of clicked to me and I could explain it. So then what I decided to do is the day afterwards, this was the most recent release of Kubernetes, so 1.2. For any of you that are familiar with 1.2, there wasn't even a thing called deployments at this time. We were talking replication sets. So stupid me just decided, oh, I know what I'll do. I'll just deploy it to production. Like, what's the worst that can happen? I'm a consultant. They'll just trust me. I'll just install it. There'll be no problems with this whatsoever. We couldn't move forward because we had port conflicts. Let's just deploy Kubernetes because I know it at least solves port conflicts. Well, then this happened. This was me leaving the office a couple of days afterwards after we'd got some applications running. I actually did go back, by the way. And then if we kind of roll forward, what I felt like was 75 years later, because I had multiple boardroom meetings where I had to explain myself why installing a 1.2 version of something in production was a good idea. Then last year, I actually was on stage. So I was on a different kind of stage. So I went from being on stage, accepting awards for playing football. Now I'm on a stage talking about what I did with Kubernetes and how you can do kind of Kubernetes security, which is kind of interesting because the security one was relatively low, which I found was actually relatively interesting, but the complexity was miles up, which I actually agree with because Kubernetes is a complex beast. Now I do this. So I started off as a developer. I went to a platform engineer, and then I kind of checked this thing out called GitOps, and now this is where I spend the majority of my time. GitOps is really about a way of being able to reconcile resources from Git into your Kubernetes cluster. So what are the main learning curves that I've gone on in the past kind of 18 or so years? The first one is overcoming challenges, right? When I was 18 years old, I thought my career was over. I spiraled into depression. I threw my bed through my bedroom, like window, like completely through. The bed was actually on the other side of the room. I had no idea what I was going to do. I was freaking out and panicking, right? But with Kubernetes specifically, there's so many complex concepts that the only way that you truly understand something, I believe at least, is to just dig into the weeds and keep banging your head against the wall until something actually fits. And then staying updated, right? The pace of change, specifically in the CNCF landscape, is like a new project is graduated or incubating like every other week. And it's really about picking and choosing the ones that you're interested in. You can't possibly learn everything, right? So I talk about kind of being that T-shaped person that a lot of people talk about. So have kind of a wide breadth of understanding about, a wide range of it, but really specialize in one of them. And then I leverage resources, right? Whether that be books, whether that be podcasts, whether that be YouTube, there's a plethora of resources available to us that we should be leveraging. A number of books here, the one by Kelsey, for example. There was, thank God it was Kubernetes that Duffy and Joe Bader started ages ago. And then really leveraging the community, right? I don't think I would be here talking about what I've done without going to KubeCon. And I went to the first KubeCon in London, and I'm glad it's coming back. I actually hoped it was going to come back to London this year for the anniversary, but alas, it didn't. Hands up if anyone went to Paris. Yeah, so there was 13,000 people in Paris, and I found it ridiculously overwhelming. But actually, it was a good mixture of people trying to sell you products, but also practitioners talking about what they'd done with Kubernetes. And then blog about it, right? I think we need to get in this habit of actually blogging more, right? I've blogged a bunch of stuff, but some of the English is suspect on it. But really, we shouldn't all be trying to achieve the same things. And the more we blog, the faster we get to the end destination. So when I was doing that poll and I was talking about Kubernetes and being complex, we need to get to a situation whereby we get rid of all of this boring stuff and we just kind of focus on what actually matters, which is the business value of your, of your organization. We need to stop trying to work out how we're going to do observability or how we're going to do runtime detection. These things just need to become kind of second nature to us. And we just install these plugins into the Kubernetes cluster and just kind of forget about them. That would be my ideal world. And then kind of it allows us to be able to help other people, right? So other people that were in my position or not in my position, we can kind of get them up to speed faster and they can, work out what they really want to achieve. So key takeaways for me is like leverage the community. All of us are sit here today listening to me yabber on, but afterwards everyone's going to go to the pub, right? And we need to get into the situation of where we can have open and transparent conversations with each other, network, talk about things, disagree with each other. Disagreements are good, right? People shy away from having disagreements, but actually disagreements is a really valid thing to do. But as long as you meet people in the middle and actually listen to what they're saying rather than what they're moaning about necessarily. And it's lifelong learning, right? We're all here today. There's hundreds and hundreds and hundreds of applications that seem to be getting released that will help us solve the next problem. And it's really about staying up to date as much as we can. It's impossible to stay completely up to date. And then it's really about resilience, right? Overcoming those setbacks. I thought when I was 18, my whole career was over, right? But I had to adapt and I had to change to, rather than being a footballer, to do something else, right? And without being adaptable and falling over and, going in and breaking it in production and deploying Kubernetes 1.2, which was a stupid idea. But looking back, I learned a ton of lessons from it. And I think this is an important piece, right? Get comfortable being uncomfortable, right? Unless we step outside of our comfort zone, we're not really going to make magic happen, right? We all like to be comfortable doing what we're doing. But actually, if we step outside, we can make massive difference to ourselves, but also to the teams that we're in. And why pursue a new career, right? And I think it's about, chasing the dream that you currently have and the skills and experience that you have in a certain hobby or a certain skill set are actually more transferable and more valuable to a team than you actually probably think they are. And it's really about encouraging and exploring and innovating in technology. So I want to kind of leave you with two quotes from a book from Stephen Bartlett, who I'm a big fan of and actually have met. That raises some eyebrows with some people I know. But really, we need to disagree less and understand more, right? We need to start meeting people in the middle and listen to what they say. This is a long ramble. I don't expect you to necessarily read all of it, but it's really with no risk, you make no reward, right? I took a massive risk. I could have gone into something to do with football, but it wasn't really my passion. And I took a huge risk and a gamble, and I went and learned technology. And actually, luckily for me, it paid off. And if I can do it, you can do it, and then anyone can. Thanks.
All right, thank you very much, Steve. We've got about 10 minutes for questions now, so I'm going to take over your screen share again. Okay, so anyone wants to ask a question for Steve, they can either use this or you can type your questions. I love that you said community and lifelong learning were two of the takeaways, because that's one of the reasons I really enjoy this community. I love getting together with people in these meetups. Okay, what happened with Kubernetes 1.2?
Yeah, that's I don't really want to relive this memory too much, but what happened was I thought it would be a good idea to run a database on it, because why not just run absolutely everything on Kubernetes at the time? Yeah, it turns out that 1.2 wasn't the best version to be running a database on. Yeah, and we decided that we'd put the main database that 3 of the applications would interact with on Kubernetes. It went down, the applications went down, and everyone started to come around my desk and say, we can't access anything. And at this point, we had kind of no observability of anything that was going on. It was just nothing's working. And then the kind of director came in and said, Steve, nothing's working. What's wrong? And I was like, I also have no idea what's going on either. And yeah, hence that was me kind of leaving for the day when the thing was burning down. But alas.
What is your next big risk?
So my next big risk, I was actually saying to Alex there, was for the last 6 months, I haven't worked at all. I took time off to deal with a family issue, but actually I went completely off the grid. I turned my phone off. I turned my laptop off. I just had my camera, and I just went and explored the world. And actually, we're so connected to our mobile phone. When we put our mobile phone down, there's a whole nother world. And yeah, that was the biggest risk I've done. I haven't done anything for the last 6 months. I've done a tiny little bit of consulting with a couple of companies, but yeah, I decided that I wanted to disconnect and go and explore and see the world. So that was the risk. I don't know what the next one is. I actually need to go back and make some money now, but that was the risk that I made at that point.
Risks, I see.
How did I get out of depression? That's a really good question. So counseling to start with. And it was very hard for me to open up at the time, right? So if we go back to when I was playing professional football, I had a lot of friends. When you don't have professional football, you don't have any friends. All those friends kind of disappeared. So they were only really my friends for one specific reason. And it was because of the cash that I had in my pocket when we went to McDonald's, because I knew Steve would pay. When Steve can't pay anymore, they'll go to McDonald's, but there's no point in me going with them. So it's really about opening up and talking. And I think that's one of the things that we need to do better as a community, is actually keep going with these conversations and actually talk about things and problems. It was that, and also putting my passion into something else. So I was up every morning at 6 when I was playing football, and I went to bed at 9, and I did exactly the same thing, but I wasn't in the gym, and I wasn't swimming, and I wasn't doing yoga and ballet and all that kind of stuff. I was learning PHP, which turns out to be a complete waste of time. But I learned a bunch of other things as well. And it was really trying to work out what my passion was. And my passion was like working directly and using the kind of the team culture that I had as a captain and engaging with other teams and actually helping them. So one of the things that I like to do in my role is not just be able to focus on one team, but be able to talk to multiple different teams and work with them and see how we can strategize and stuff like that.
Can we take a question?
Sure.
Earlier in the slides, you talked about performing under pressure. And if I caught it correctly, you mentioned that we should be prepared for situations like this. So I'd like to mention that I kind of disagree with that, because if you're prepared for it, you somewhat eliminate most of that pressure. So if you truly want to be in a situation with the pressure in place, it needs to be a crisis, you need to be in crisis mode and you have to have no idea what to do. Then you will feel the actual pressure.
Yeah, I would agree with that, right? But it's about practicing, right? If you imagine those penalty takers that we're talking about, you can't truly replicate going and playing in the semi-final of a World Cup and taking a penalty shootout to get your country through to the final. It's impossible, right? But what you can do is you can spend a lot of time practicing and try and replicate that scenario. Who am I going to choose? Which 5 people am I going to choose? Incident, which people am I going to have in the room? Who are the key people that I need to have available? You're never truly going to replicate that exact problem. But then what you have to do is try and do like red blue days, right? Where someone's trying to hack you and you're unsure what's going on. And then you're making sure that your kind of observability and your incident response is kind of up to scratch so that when you do have an incident, you've at least got some guarantee that you've got some kind of process. I agree with you that you're not going to truly be able to replicate the absolute disaster zone. But there are a number of smaller subset of disasters that you can kind of practice for. You can never practice for everything.
Thank you.
Thoughts on Ten Hag? I don't know who asked that, but I would keep him. He's been put in a very difficult position. And if you look at what's going on above him and also some of the decisions that he's made are questionable. But yeah, I don't necessarily think there's a better person out there right now. And he needs to be set up to succeed, and he hasn't.
Okay, last one, and then we'll go. I think it's which academy did you play for?
I actually can't legally say that because I was in a legal dispute with them when I went into depression. But it's a club down south that plays in red and white. That's all I can say.
Okay, thank you very much, Steve, for sharing. Everyone, round of applause, please. All right, we're going to welcome our next speaker of the evening, Stephen. Okay. And over to you.
Hi, everyone. I have been cursed. We said the slides would work earlier on, and now we're going to find out. Okay. Hi, everyone. So this is a talk about platform and DevOps. There's a lot of stuff with our platform going around at the moment. A little bit about me. So who am I? I started out in hosting companies in the 2000s. I was really lucky. I had my hands on lots of kit that I really shouldn't have been allowed to be configuring. Everything from every kind of switch, hypervisor, firewall, router, everything from big M5000s with hardware partition Dell DOMs to Citrix and whatever. And then I've just been very lucky. I've gone on to work in projects to build private clouds, work in public cloud. The team here is a really great one, working in data at Jet. We have 7 teams, 39 people, and we're scattered all over the place. It's a truly global company. So we're in Ukraine, Canada, Amsterdam, London here. It makes for interesting sort of meeting hours. I think it's just coming up to 5 years I've been here. And, in that time, I've done some stuff with cloud networking, but mostly I've been working here with data. So my role is quite a broad one. I'm a technical person, but I'm supposed to help with direction in various types of things, helping everyone to collaborate, make decisions on the future architecture of the platform, as well as introducing new ideas and trying to make things work. Just this is the obligatory slide from the slide deck from Jet. We are a very big company. Well, I mean, there are lots of big companies in the world, but we're fairly sizable. We have, 20 different countries, millions of users, millions and millions of orders. And almost all of those orders and all of those markets come into the Jet data platform. So I was checking with someone earlier on today, and we're up to about 27 billion in the last 30 days for real-time ingested messages. We have like many different Airflow deployments, all specialized for different tasks. Thousands and thousands of DAGs. So Optimus, our main transformer, it's like 3,500. Egress, getting that data back out of the data platform is, getting up towards 3,000 now. But there's just some highlights. We have many different projects. I was remiss in trying to work out how much data we actually still have stored in BigQuery. It's a lot. But multiple GKE clusters, multiple Airflows, data flow. We have jobs and services from Google Cloud spanning many different projects, and many users. So all of those markets have people doing reporting, and I think 6,000 licenses for Tableau. Okay, so I started 5 years ago, and when I started, this platform was already a great platform. We'd moved from AWS to GCP, and there was a real kitchen sink team of some brilliant people who had moved the data platform. But the data platform grew. So it's a big business. There's many markets there. Just Eat, they acquired Skip the Dishes, and brought on a new market. And at that point, we had some growing pains. I think it took about 45 minutes to plan an environment with Terraform. Getting changes into the system to try and move quickly was really difficult. We spent a lot of time refactoring that code, taking the Terraform modules, which I'll talk a bit about, and making the state unique. So having per module, which were really well written, per environment, per thing, an individual state, because Terraform gets very brittle when when it gets big. We spent a lot of time making the environments the same. So, we, inherited these brownfield, and we had Airflows, and some had RabbitMQ, and some had Redis, and there were lots and lots of differences. You deploy one thing in one environment, and then it wouldn't work in another, and all those good things that you want to have to help with testability and reproducibility. So we got there, and one of the people from the team left. They got a really nice offer, but then unfortunately another person, so they got an offer from Google and they left. And then one of the guys, he had a baby, and he went on sabbatical for several months. And so we had one person left in infra for all these projects and clusters and Kubernetes clusters, which, as you know, you have to install a whole bunch of stuff on to make them work and keep them updated and keep everything running. So what do you do? If this, I think, is referenced in Accelerate, which I'll talk about later, and it represents what happens when a work queue gets busy. You have one person, they have lots of tasks. Someone's tasks are quadrupled. The busier you get, the longer your wait time in that work queue goes up. And so one of the things that DevOps methodologies help with is trying to address problems like that of scaling, and how to get the work done. This is the best picture of a platform I could find. So there's a lot of stuff talking about platform now, and we had a really great talk in the last talk, the last meetup, about nice abstractions that are starting to come out for what platforms are, and they make a lot of sense, right? They're very useful, like developer control plane. Sure, they way that we do it is we avoid building a GUI on top of things. We have some stuff in Backstage for creating access and creating projects for, how we assign slots to teams and stuff like that. But, our major interface is version control. You check something into Git and an automated pipeline will run and it will do some kind of work for you as a category of work. The model on the left, which I'm sure you've all heard of Dora metrics and stuff, but I don't know if everyone's actually looked at the model. So I'm a huge fanboy of this. Dora has a long history now. I think Accelerate came out in 2018, something like that. And we're 2024 now, so that's 6 years ago, so it's kind of scary. But basically what they did was they took a lot of data from the State of DevOps reports, and they used factor analysis, which is something they use for like the big 5 personality questionnaires and the inventories and stuff like that. And they pulled out these latent variables, and these are the variables from the data that make teams effective. These sort of things are what high performing teams do. And I, started out when we had ITIL and ITSM, and there was just like a whole bunch of stuff that people had built up to say, this is the way you should operate. But the environment changed, the landscape's changed, and we went from building servers to just calling an API. There's lots of really important stuff in here. I can't stress enough how important it is. A lot of stuff about DevX at the moment, which is really interesting. We get really good feedback for the tools we build and the interfaces we try and build with our teams to try and help improve the platform. But I'm going to just talk, because we don't have very long, about just a few of the facets of some of the technical aspects of Dora. So there are technical practices at the bottom. I'm going to talk a little bit about things that, I'm sure we all do, and it will sound very simple, but, version control, trunk-based development, continuous integration, deployment automation. I apologize for this diagram. We have created golden path pipelines. And so all of our infrastructure parts follow this pattern. We take all the different dependencies we have. They are independently versioned. So we're continuously integrating, but we're continuously integrating for each one of the dependencies. And we, I really like XP. I like people sitting next to each other. I like to be able to do code review as we're doing things and discuss things. I like to commit frequently to master. Unfortunately, in a big business like that, one, we're not allowed. We have rules in Git which prohibit us from committing directly to master. But also, I'm often talking to somebody in Ukraine or Canada, or, and you can use tools to help bridge that gap. But actually, it's difficult to work like that. I mean, XP works really well if you have different tiers of people in your team that can work together. But if you're very senior heavily, like we are, there's a very few number of people, then actually, XP is great, but still maybe not the best use of everybody's time. So we have short-lived feature branches. We're tagged on master. As soon as you've ended some code, you get a review on your branch and it goes straight to master. We hit a tag. So whenever there is a piece of code, we push tag. Wherever there is something, we build an artifact. And then instead of moving that artifact through the CI system, we just take the information for that and a reference to where it is and what version it is. So if it was a Docker image, you'd build it, you'd push it, and you take that and pass it between the builds. So build hierarchies are not a new thing. It's just a neglected thing. And I got a story about that towards the end. Now, we go one step further. So we then integrate all of these different dependencies. So it's kind of continuous integration for your deployment. Now, I don't know what you'd call it. We've called it over the years a graph file, manifest. There's a lot of stuff about software bill of materials at the moment. This is kind of it's like a deployment bill of materials or something, if you like. But a fixed set of versions. It's a flat dependency graph of these all the things that it takes to deploy my application. And You know, it might be you're on a Kubernetes cluster and you have a Helm chart, you have the configuration of the Helm chart, you have another service that you're running, maybe it needs some disk, maybe it's got NFS, maybe it's got a cache for some Redis or something. So the configuration for all of those things in the Terraform modules all have a version. They go into this graph and then you pass them to the deployment pipeline. That then makes it sort of directed and acyclical, a bit like the DAGs that we deploy in data. The same code runs in each environment, so you get that reproducibility of my code runs. If it runs in one environment, it should run in another. It should run in another. All things being equal, which you have to work hard to make sure that everything's the same. This is from Concourse. So we've gone through migrations here. We started with Jenkins, then we went to Concourse. Now we're all on GitHub Actions. We've moved everything. This was the one pipeline I could find still in Concourse because I really like the Concourse resource model. And the UI is actually really great for visualizing your pipelines. I'm not complaining about GitHub Actions at all here. But if you look at this, what you'll see is a whole bunch of different dependencies. And this was like 5 years ago, I think we did this. Like, I think when I started, the Jenkins hadn't been touched for about 5 months. And you know, when there's like all those plugins just sitting there and no one wants to touch it and hoping it's not going to restart because they don't know what's going to break and everything's deployed by it. And it was one of those situations. So one of the first things we did was we built a pipeline. And this is a good example of one of our pipelines. Everything's moved on quite a bit since then, but you know, there's we had a role data app. We use JCask. I love JCask. If anyone's still using Jenkins, JCask is your friend. And JCask picks up from a repo. We have everything in everything for the jobs in code in job DSL. And so what would happen is we treated Jenkins like a real Java application. We have a couple of different environments. So you want the fastest feedback on your left. So each one of those builds has tests. They run. If they run, it triggers then the next one, which bundles them all together. You pass that to the deployment pipeline. And it's really great. Your first environment, you want to come up quickly and you want to know whether something's broken. So it comes up. You know that all of my plugins at all of those versions will work with the keys that are configuring them in JCask. And this was on Kubernetes as well, which Jenkins on Kubernetes is pretty strong. It just meant that we had a really fast feedback loop for testing. It then pulled the jobs, configured them with a seed job, and then we had pipelines which used the shared libraries of the different categories of pipelines we had. So then we test that those types of pipelines work with our plugins, with the different versions of the keys and everything that's in the plugin configuration. And then you could have another environment for testing, but after that we just went straight to production because I don't know, we're brave. It was an improvement on the not using or updating anything for 5 months anyway. I apologize for this diagram. It was very hastily drawn, but I was trying to, when we were working out what our types of pipelines were going to be, we had to look at what we were provisioning, what the cadence of those builds were. So, we have many projects. Everything runs on top of those projects, GKE, but we also have lots of data flow jobs. We have cloud functions. We have, like our jobs for DataStream and CDC. We have Airflows, and for that we built a package to deploy and distribute Airflow, which we'll talk about in a bit. Apps, and then DAGs. So, golden path pipelines for each one of the different types of deployments that we have, split by layers with, like, this is my frequency of deployment. And when we've got an environment called InfraDev, where we deploy all these different layers. And we're able to test before we promote into other environments how things work. Okay, so that is our project pipeline. So each one of those deployments in each one of those environments is an imperative set of steps. You take the versions of everything that's part of the deployment pipeline, you take those versions, and then the pipeline uses the things at those versions. It sounds simple, but actually, it's a really nice way to be able to test, roll back, test again, roll back. Each one of those things runs every time. Now, some people say to me, well, isn't that slow? And I think that one there, I try and keep every single environment release under 6 minutes for every different thing we have. It's just enough time to get a cup of tea. There's lots of really interesting stuff from sort of cognitive neuroscience about like how long you can leave a problem and come back to it before you have to load that stuff into your mind. Like, I don't know if ever you've like written any Java. So you're sitting there and you leave it for more than 10, 12 minutes and you come back and your build's failed. And then you just have to load it all back into your memory again. And you're like sitting there and I'm just scroll back up to this method to work. And I scroll back down again, up and down. And that has been shown to, that kind of feedback cycle, not being able to go back to your code, it costs time. And a lot of the stuff I'm going to talk about is to do with how you save time and make your developer experience better. In terms of deployment, we parallelize everything we can. So say we're launching something and it has like Airflow has file store. It has Redis. If you're using the Celery, it has node pools. And the longest call to the cloud provider at any one time is 10 minutes. So we run a couple of things in series, then we run everything you can in parallel. So our time is just the longest time for that call. When we started, the guys who started, it took a few weeks to learn how to build Airflow the way that we do at Just Eat. We've got our own charts, our own images, like everything's very specialized. We have the build time down now to about 13 minutes, which is kind of cool from weeks. And it helps to solve that problem. When you're trying to run a platform at scale and you have situations where you have people and you lose them, you've codified all of the information that it was in someone's head that deploy this complex thing into a pipeline. So even if someone comes fresh, as then you guys did when they joined, they can read that pipeline, they can see exactly which dependencies went into it, and they know exactly how it's built. It's a real advantage. Being conscious, this is just, actually, I stole this from a Miro board from like ages ago, where we were starting to discuss the actual progression and promotions in here is sort of immaterial. I think this was our projects and we were trying to decide how we would go from having hard-coded versions of all those inputs, especially for things like Terraform modules, to dynamic ones. Terraform is really hard. If you're trying to version, if you have a reference, because you're going to pull a module at a specific version, then when the Terraform init runs, you can't use a variable. I'm getting looked at here. I'm very, very slow. I'm sorry. I'll speed up. Yeah, it's at a specific version, and it's very difficult to distribute amongst a whole different bunch of pipelines without having to go into the code. I've got to change the integer or whatever I'm using for my reference to the Terraform module and keep going. Well, what we did was we used that list of dependencies, Terraform module versions. We just changed the Terraform modules to reference everything locally, and then got everything to the working directory of the CD server at the correct versions and ran it. So now we have our CI/CD doing the thing that CI/CD was supposed to do. Instead of people doing the work of like updating Terraform module versions, our machines are doing it for us. Testing is really interesting, and working out which environment do I test which thing in, so that I can get the fastest possible feedback and deploy the most stably. So when I get to the end of it, my pipeline for production is green is really cool. This is also about performance. So we build, we run tests, we tag something, or we build an artifact. So build hierarchies are important, especially when you're running a platform. If you've got thousands of users doing lots of things, You have to be able to have modular code, be able to have it instrumented, look on aggregate at how long things take to run, to be able to spot gaps. And there's a, British cycling team is famous for, marginal gains. But so I think it was Optimus queries. So that build's used by a lot of people, and it ran like 1,000 times a day. But in the beginning of each build, when they were doing the testing, you would build a Docker image, and then you would run a pip install with like loads of libraries for Nevo. And this would take about 3 minutes. But if you look at the cadence of that build, it didn't change. Like once in every 1,000 builds or something, someone changed the pip install file. So what we did was we took it out. We built the image, we versioned it, and then we promoted it into the next build. So 3 minutes build, 1,000 builds a day. I had to write these numbers down because I was never going to remember them. And forgive me if my maths is wrong. It was done in a hurry. So, 300 minutes per day. If you assume 252 working days a year, that's a lot of minutes. Now, if you turn that into 24-hour periods, that's a lot of 24-hour periods. And there were 4 builds like that. Now, a 24-hour period is a solid 24-hour period of build time. But if you divide it into working days, so it's 8 into 24 goes 3. I mean, that's a lot of time. That's a lot of time where our users could have been doing other things, not waiting for a build. In aggregate, across all of the different people using this, it was like a huge amount of time. And I really like looking at stuff like that because it just means everyone gets a little bit done just a little bit quicker each day. Okay, if you haven't read these books, you should. And in fact, everything by IT Revolution Press is great. I promise I'm not paid by them to say that. But of all the books I've read of technology, Accelerate is by far my favorite. And if you need help explaining to executives and management why you should make these changes, what's the reason for making, for this rework, for restructuring your deployment pipelines, why is it worth the effort? This book will really help you. Okay, thank you very much.
We have about 2 minutes for questions. So I'm not going to bother to put this screen up at the moment. Anyone want to shout a question? Can you pass this back to Steve? Oh, okay, I'm going to try and throw. Take a risk, right? Take a risk. Hold on. We need the microphone for recording. Steve? Sorry. There you go.
What's your favorite DORA metric and why?
I don't know if I have a favorite. I always thought it was interesting that deployment frequency was like a proxy for batch size. I'm not sure whether I really agree with that or not. I mean, it's definitely useful. But yeah, I mean, they are metrics that you do and look at how you have performed, as well as DevX is a great thing that you can do up front to get feedback on your platform. But yeah, they're a really good thing to do in Instrument.
Oh, let's try and get the microphone that way.
Cool.
Oh.
It's a long clearance there.
Hello. So why do you choose GCP instead of rest of the clouds?
I mean, there's lots of different reasons. For data processing, BigQuery is a really great differentiator, honestly. It scales amazingly. Additions now has become a thing that we depend on quite heavily. And the auto scaling is like really, really useful in terms of trying to buy and then scale at times. So we're busy during the day when we have all those users doing things. And so buying capacity planning, really important. I honestly think Google Cloud is a brilliant cloud. I don't want to disparage the others. I've worked in some of them and they're great. I find that the services are better integrated. It's almost like the Google teams talk to each other, unlike another cloud vendor, which we all know who that is. And yeah, everything's very slick and easy to use.
Okay. The one last question. So in cost perspective, so how the good GCP comparatively other clouds?
I mean, I don't know. You'd have to be running equivalent workloads and things. Like I said, a cloud is as expensive as how you use it. But I find there's a lot of advantages to Google Cloud in a lot of the different ways that their services work and are configured that help you to work smarter and cheaper.
Thank you.
Thank you. All right, we're going to take a minute now to do the raffle. So do you want to come on up? And everybody can help me with a drum roll. We're going to do 2 drawings here. So first one, drum roll.
$19.
Who has 19? Wait, oh, what do I have? Okay. 19. Last chance, no. All right, we're going to do, oh, yay. All right, 1 for you. Okay. Hand over the prize. Yep. Okay. You can keep doing. Okay. All right. Second draw. You want to come and stand up on the stage? Stay on the stage. Okay. Second one. Here we go. Here we go.
It's not unusual for my to come in. And we have
27.
27. Yay. Okay, we're now going to go to a break. I'm also going to cut into this cake, so please, everybody, help yourself. Come back at 8 o'clock for our third talk. Thank you.
then we'll go.
Maybe it to cross. So it was stand. Sorry? Oh, you said it notation? Wow. Yeah, okay. And so on. So you from this is training or Russian, like which language? Russian. I need some either of these two languages. Which part of Russia? Which part of Russia? Oh, this one. Okay. I had my ex-colleague, so he went to Russia. So we were working on the same team almost 6 years. So it's nice. He's a tough guy. And later he's very chill. We had a good time. Initially, like it's very. He was in the project almost before I go, before 5 years. So he knows everything. I was joining newly. Then initially it's a to catching with him and stuff. Then later he's a chill person, very chill. So we used to make a conversation. We used to send this house pics, construction, and when we go out on the weekends. So he used to send all those pics. Basically, it was a very nice. Would like to have some cake? Pastry? Okay. Come, let's go. Yeah, you can keep it, no worries.
You know what it's like? There was someone on the phone when somebody yeah, good. Yeah. Yeah. And he taught it to such that actually I didn't know festival about it. Someone else. Protect yourself against it. Yeah. Yeah, that's right. to be fair, I was doing about 6 times now.
So you don't do that sports at home?
Right, folks, we are going to kick off our third talk of the night. This is cost-conscious cloud-native engineering. Please, a round of applause for Alex.
All right. Hello, everybody. Welcome back. Thank you very much, Cheryl. I'm very pleased to be here tonight and to be able to speak. It's great that we have this opportunity to exchange ideas like this in a setting like this. So I'm very excited, and I hope it's going to be fun for you, and you're going to learn some things. So I'm going to talk to you about cost-conscious engineering, and a little bit about me. I've worked on cloud technologies for the last 10 years or so. I'm an independent consultant. You can find out more about what I do at cloudify.io. But the main thing that I do is that I help businesses reduce their cloud costs. And I want to share what I have seen and what I have learned doing that over the last few years. So this is our agenda. We have what is this cost-conscious engineering thing? Why should you care? What is its special relationship with cloud native, as we are in the cloud native meetup? And a few ideas about how you actually can implement these ideas that I'm going to talk about. Right. So the first thing I'm going to show you is some delicious food. So you'll be wondering, why is that there? When I was a kid, my mom used to cook for me like 99% of the time. And when I was around 10 years old, I started to take an interest in cooking. And I would see my mom maybe discuss about recipes with her friends, or maybe she'd watch a TV show. Maybe Jamie Oliver was just coming out. I don't know. So we'd watch something on TV, learn how to cook something, a new technique. And around, I must have been 10, 11 years old. I thought, okay, I want to give this a go. So, I started from very simple things, and I said, hey, I'd like to, boil an egg. How do I do that? And she taught me how to boil an egg and, maybe some pasta, some rice. And after I got a little bit more confident, I was like, okay, I'll cook something really delicious now. So I said, I'm going to the supermarket. Can you give me like 20 quid and I'll buy some things and I'll cook dinner? She was like, yeah, sure. So I went to the supermarket and I bought like some ribeye steak and a large amount of butter. And I cooked this ribeye steak and I bathed it in butter, and it was absolutely delicious. And I went to my mom and I said, Mom, what the hell is going on here? Because I've only started cooking 3 weeks ago and I can already make delicious things. But everybody else is acting like cooking is so complicated. Like, what's so complex about it? So why am I telling you this story? My position, and this is what I'm going to try to convince you of today, is that developing software is very similar. Because developing software comes with costs, right? And I will expand upon this. What do I mean by costs? I don't just mean money. It's very easy to build something that does the work that you're trying to do if you spend a lot of money on it. It's very difficult to be efficient with very little, to squeeze out the most that you can out of little hardware. And my position is that as software engineers, we must involve cost analysis in our process at all times. So what are the costs of software? So first of all, we have the engineering time that you need to develop something. So you're going to hire a few people, you're going to pay them for some time, and maybe they'll need, let's say, 6 months to build this software. Okay, so that's one cost. And actually, you can get like a number of pounds that you paid these people for these 6 months, right? Then you have to think about other costs, because once you've developed the software, you can't just leave it there and it just runs. You need something to run it on. You need people to support it. You need to update it, upgrade it. You need to debug it. When it goes down on the weekend, somebody has to go on, look at it, fix it, call other people. So there's a lot of things that you need to take into account. Cost of talent, what do I mean here? You'll notice that the longer you've been in the tech industry, there's always waves of specific technologies that come around. And for the last few years, that has been cloud technologies, Kubernetes, Golang has been a very popular one, Terraform has been a very popular one. All of these things really solve problems that we've been seeking to solve for, a lot longer than these technologies have existed. They're just different implementations of attempts to solve these problems. And when companies hire people, they look to hire people typically for things that are easy to hire, right? Nobody wants to hire engineers for a programming language that nobody likes, that nobody uses, right? It's a lot easier to hire somebody who works with Python, for example, because that's very popular, JavaScript, Golang, these are the most popular ones, so it's easier to hire. Then we have cost of hardware. In the old world, that will have been, servers and machines, maybe load balancers, whatever other hardware you needed in your private cloud. In the new world, it's your AWS, your GCP, your Azure, et cetera, et cetera. And then we have related infrastructure, because when we run a system on AWS, let's say you run it on a container, just the container engine and the container platform, let's say Kubernetes or Docker or whatever, is not enough. You're going to need load balancers. You're going to need proxies and caches and this and that. And this is also the supporting infrastructure. You're going to need your CI/CD platforms and your Jenkins, et cetera, et cetera. So all of these costs contribute to, all of these things contribute to the cost of whatever you're building. In cost-conscious engineering is the practice of building systems with those costs as a primary concern. Right. So let's dig a little bit deeper here. Oh, if we can move, there we go. So why should you care? So the first thing is that if you can build whatever you're trying to build in a cost-effective way, that is a major level up. It forces you to think deeply about your software. It forces you to become a master of your craft. It's easy to, let's imagine a scenario where I say to you, you need to be able to process 1 billion rows in SQL. Okay. Can you do this on a machine with 1 gig of RAM and half a CPU? That's one task. Can you do it on a massive machine with 100 gigs of RAM and 55 CPUs? That's a much easier problem, right? You don't need to implement any clever techniques to achieve that. You can just load it up into memory and it will work because you have a massive machine. If you need to solve problems on smaller infrastructure, then you really need to think about clever solutions and maximize what you have available. The other reason that you should care is because cost effectiveness is the cloud native way. And what do I mean by that? So I've taken some screenshots from the documentation of some major cloud providers. This is from AWS. And you'll notice that they say the headline is, what are the benefits of cloud native application development? And I've highlighted cost-effective operations, right? Being cost-effective is one of the promises of cloud native. This is Azure. So Azure combines sort of the idea of cloud native with the idea of microservices, and it kind of puts it together. They're not exactly the same, obviously, but there is some overlap there, especially in the way they present it anyways. But they as well claim that this cloud native way helps reduce overall costs. And then this is GCP. Again, lower costs is one of the main things that they claim you can get with cloud native. This is, what's this? This is, whoops. This is, I believe that's IBM. It's either IBM or Oracle. Oracle, there we go. So they also claim the same, that, you know, there's cost efficiency is one of the main things you get. And this is IBM. They also claim that cost savings and operational efficiencies are one of the things you get with cloud native. So basically, every cloud provider tells you that cloud native is more cost efficient. And yet, I keep seeing posts like this on Reddit. This is an interesting one for a few months ago, where this guy says, basically, they had a small startup and they forgot about some EBS volumes. They only realized 3 years later. And in the meanwhile, it had cost them about $500,000. Now, obviously, these guys are have made a massive error in forgetting these EBS volumes for 3 years and not realizing that it was costing them so much. But I keep seeing other things like this very interesting blog post from about a month ago. And this guy talks about this weird scenario where an empty S3 bucket can make your AWS bill explode. So this is a unique misconfiguration of an empty bucket, basically, which ends up costing you tons of money. Okay. And then we have things like this. I have a post here. This is from Reddit again, but you'll notice that this guy's basically saying, I'll summarize it for you. When you have a service on AWS, sometimes you might put a load balancer in front of it because the load balancer gets a certificate. So it's just an easy way to get SSL in front of it. So you put the load balancer, you get the free SSL. Great. But the load balancer costs $20 a month. If you have like 100 services, straight away, that's $2,000 a month. However, AWS allows you to set up a single ALB and then have hostname separation, basically. So you can load up 100 certificates on the one ALB. So then you only pay for the one ALB, which is $20, and you still have the 100. But basically, you have to do like some weird trickery just to get the thing that you knew you wanted anyways, right? You just want the certificates, but they don't just give you that. They make it complicated to get there. At the same time, over the last few years, there's been a trend of certain businesses thinking about whether moving to the cloud was actually a good idea. Maybe we shouldn't move to the cloud, or maybe we should return to on-prem servers, private clouds. And this is an article from, I forgot where it's from, but I can figure that out. Where their claim is that cost predictability is one of the main things you get if you don't use the public cloud, right? So in direct opposition to what all of the clouds were saying, they're telling you, oh, if you use cloud native stuff, it's cost effective. These guys are saying, actually, if you don't use cloud native stuff, that's cost effective. Okay. I have another example here where it says bare metal solutions are more cost effective for their particular operations. Okay, so what gives? Well, as always, it's nuanced and it depends, but there is some fine print here. And cloud native in general has a massive barrier to entry, right? Because you have to learn about Docker, you have to learn about Kubernetes, then you have to learn about your cloud, AWS, Azure, GCP. You know, you have to get, there's certifications for each of those things, you know, so many things to learn. Then you want a service mesh, you learn about Istio and, you know, Linkerd or what have you. And then you need something to look at the metrics. So you have to figure out how to run Prometheus. Then you have to figure out how to run Terraform because you have to automate all this infrastructure. You have to know about Ansible and you have to vault for your secrets and serverless stuff. And there's just so much that you have to do. It's just endless things that you have to learn before you can basically take advantage of what this offers you. And yes, cloud compute in general is cheaper unless your developers spin up servers for the tests and then forget to turn them off for 3 years. And unless your software has predictable load, in which case, if you know you just need 10 servers, it's much cheaper to just buy 10 servers and have them there. Unless your servers are like 10% CPU and memory capacity all the time. That's another problem that I see in a lot of businesses that I've worked with. Basically, they just have these EC2 instances, and all of them, you look at the historical metrics 3 months ago, the last 3 months, peak at 10% CPU utilization. Of course, that's not the only metric that matters, but it is an indication that you're not really taking advantage of the hardware that the cloud provider is giving you. And that costs money. Basically, you pay for that. And then there's also bugs, right? I don't know if you've ever faced this, but I've seen this a few times where somebody basically forgets a thing that keeps calling a Lambda or keeps calling an API gateway. And basically, they find out sometime later that, oh, our Lambda accidentally got triggered 10 billion times. And, that costs money again. And unless you forget to read the full pricing documentation for the service in question. So if you look at AWS, Google Cloud, they have hundreds of services. We're all familiar with the more, common ones like EC2, let's say, and S3. I would imagine almost everybody has heard of those, but there's hundreds of those. And each one of them has a separate pricing documentation. There's a lot of text to go through. And I'll tell you a little story from when I was working with somebody. It's totally not me. So this is a story of S3 and Glacier. And for those of you who don't know, well, first of all, S3 is object storage on AWS, right? You store objects on there, so files, you upload things. And Glacier, so basically S3 has this concept that you can have infrequent access objects, basically, where you say, actually, I don't need to access these all the time. I probably will never need them. I may need them at some point. And when I need them, it's okay if I wait for a while until I get access to it. So that's basically Glacier. And they say, okay, if we put it into Glacier, you're not going to have immediate access to them, and but it will cost you a lot less. Cool. I have a massive S3 bucket with billions of files in it. I want to put them all on S3 Glacier. This is a really long time ago, by the way. This is more than 6 or 7 years ago. Okay, so move all the files to S3 Glacier. Now, something that may not be immediately obvious is that S3 charges per request, amongst others. So it's very different to have, let's say, 1 petabyte of data in 10 files versus 1 petabyte of data in billions of tiny, tiny, tiny files, right? Because if you have to change the storage, I forget the term for it, the store, does anybody remember what they call it, what AWS calls it? Storage tier, yeah, tier. If you change the storage tier, it's a very different story, changing it on tons and tons and tons of tiny files versus a few really big files, even if the sum of the data is still the same. So basically, somebody went in and ran a few billion requests of saying, change this file from standard tier to Glacier tier. And the next day, the bills showed about $100,000 US in charges on S3. People freaked out. What the hell is going on? Luckily, we were able to get a refund from AWS support. They were very nice about that. They recognized there was an honest mistake, but it just goes to show. And then we have blog posts like this. This is an amazing read, by the way. I recommend to everybody to Google this and go and read it. It's an awesome blog post. It's called I Accidentally Saved $500,000. I really enjoyed the way this guy writes. So he says, I saved my company $500,000 in about 5 minutes. This is more money than I've made for my employers over the course of my entire career because this industry is a sham. I clicked about 5 buttons. So I could relate to that. Right. So I think by now I've shown that this is something that we need to think about a little bit deeper. And now I want to switch gears and talk to you a little bit about what can we actually do. And the first concept, or one of the concepts I want to talk about, is mechanical sympathy. This is from the AWS documentation again. And basically, mechanical sympathy is a concept that refers to being able to use the system that you're using in a way that you're taking advantage of the system itself, right? You're working with it. You're not working against the system, right? You're playing to its strengths. And this is about ultimately taking advantage of what you have available versus what some people do is throw more hardware at the problem and hope that fixes it. And I've made reference here to a Git repository on GitHub. And this is from Arden Labs, which is a business that offers training for Golang. And I want to show you an example, which is something that interested me. But basically, this is from a training that these guys offer. And they have this code. You don't need to understand this code. It doesn't matter. But basically, what we see here is that the guy shows, oh, you cannot see this. Sorry. I thought I was sharing this. My bad. I'll switch real quick. Can you see this now? Yes. Okay, so we have some Go code here. Like I say, don't worry, it doesn't matter. You don't need to be able to understand this. But basically what this shows is this guy is trying to run some concurrent operations. Basically, he's trying to process 4,000 files, and he's checking different approaches to this and collecting data about how efficient each one of those is. And he has basically the same thing being done here. And he has like 6 different ways of doing it. And, he's commented out these other functions. And, this is just sequential processing of the files. And then, he has like wait groups and Go routines and concurrency. Like I say, it doesn't matter. This is not specifically about Golang. So why am I mentioning this? I'm mentioning this because this is this sort of like the summary table that he got from this. And you'll see basically it says here the total runtime, it differs, and it got better or worse depending on the method used. And the amount of memory that, the system used was different depending on the method they used. And the time that garbage collection ran was different. The point is that making these optimizations to your code, you can massively change the way that your system, the thing that you're trying to do, runs on the hardware that you have. So in this case, you see that the very same program doing the same exact thing either used 4 megabytes of memory versus 50 megabytes of memory in a different version. And basically, when you have limited hardware, this can make a massive difference, right? So what can we do today to improve our position in terms of costs? So the first thing that you should do is figure out what it is that costs you the most, right? I think that's fairly self-explanatory. In most cases, it's going to be compute or data. And if it's not compute or data, you're probably doing something wrong. The second thing that you need to do is to think, okay, let's say my top cost is data. Am I a data company? Yes. Okay, well, that makes sense. It makes sense that I'm paying the thing that I'm offering value for, that my business does. If it's not, then it's something worth thinking about. Next thing you have to look at is right sizing. And there's multiple automatic tools like autoscalers. Kubernetes offers horizontal autoscalers, vertical autoscalers. You can use requests and limits, and again on Kubernetes. A very straightforward one, don't use the same infrastructure in development as you do in prod. Again, this is a quite simple concept, but I see this time and time again, multiple businesses. They run a development database, for example, that is the exact same size as their prod database. And it's like, why? You really shouldn't need to do this. Next thing is take advantage of discounts. All of the cloud providers, they offer things like reserved instances, spot saving plans. And all of them also offer tooling that gives you automated suggestions to improve things. And usually the advice that they give is quite good. You do have to check it yourself, review that it makes sense for your specific use case, but usually it's quite good advice as a starting point. And then in terms of process, the first thing is when you're trying to improve on the efficiency, you have to know what your application needs in terms of hardware, in terms of software, right? What am I using? Am I using memory? Am I using CPU? Do I have, concurrent threads? What is it that my limiting is? What is my bottleneck? That means you need to have observability. It means you need to understand your system. And obviously, we're talking about optimization. I rush to say premature optimization is very bad, right? Only do this after when the time is right. Whoops. I have a link here, which is for another thing I want to show you real quick. So this is the popover drama, and actually it's about some very different, really, than what I'm talking about. It's about front-end engineering, really. And there was drama on Twitter because in the tech scene of Twitter, because some people were claiming that, whatever these guys were doing here is really slow and inefficient. And then these other guys were saying, no, it's not slow and inefficient, it's great. But the conclusion that this guy reached at the end is what interested me. And this guy says, software development is full of merchants of complexity. They will tell you about great engineering practices and how to optimize for the local, but they never stop to discuss benefit or how the system as a whole will suffer. I saw the term engineering used a lot in this debate. Here's my hot take. An engineer who overlooks costs is a bad one. And I tend to agree on this. Okay. Oh, and then another one, again, something I've seen in multiple companies, they deploy something because project management said, we need this thing. We're deploying a new feature next year. Okay, you don't need to run the database for it from now if you're going to start using it in a year. In many cases, the thing actually never goes live even, and they've been paying for infrastructure for this thing for nothing, for no reason. In my position is that project managers should include cost KPIs. So it shouldn't be, a Jira ticket of build a chat app. Obviously, it will be elaborated more, but it should be build a chat app that can sustain, X amount of users, for example, at less than X amount, Y amount of cost, right? And then obviously you're going to have to think about various things in terms of what, your mileage will vary and there's different approaches to solve various problems. You might do push or pull or read through, write through, serverless or not serverless, SQL, no SQL. All of these are valid approaches, but you always have to think about what is the appropriate one for you. And only what, it's within that context that you can actually be efficient with the hardware that you're given for the problem that you're given within the cost constraints that you're given. That's it. Thank you very much. And if you want to add me on LinkedIn, that's my LinkedIn. And if you want to send me an email, that's my email. Thank you. Yeah. And I will go to the pub afterwards. So if anybody wants to chat, feel free. Yeah.
Okay. All right.
Do I need this anymore?
Hi, my question back on cost is like incentive, particularly in the companies. It's easier people to say, hey, I want to do this, something put it in rank. Once I like in the BI team come back, we develop this thing. Here's a price tag. Give a number. They do not give a number. How do you like proceed negotiate on that?
Yeah, so incentive, that's a massive question. It's a very good question. And it is a problem that I have seen. And just to make it clear to everyone else, here's the problem. I can be an engineer in a company and I will do my best to be cost effective. But if the people above me, don't see that, don't reward me for my effort on this, but also vice versa, if I'm not penalized, if I'm spending a lot of money doing nothing, then what's the point? Why am I doing all of this? I'll go back to what I mentioned. It levels you up as an engineer, having to think about these constraints. But also the reason why I wanted to talk about this is because I think a cultural change is required. Management needs to think more about costs and needs to think more about how we build teams and how we build software that can be efficient without wasting too much money. Because ultimately, I basically instead of my company spending the money on the cloud providers, I'd like them to pay me. That's my point. Like, instead of giving it to the cloud provider, I'll do a really good job and I want to keep that money. That's how I feel about it. Yes. Whoa.
Yeah, this is not really a question, but I've seen the same, that most of software developers, less engineers, don't care about how much it costs. And it's really good to see that someone else sees the same.
Cheers. Thank you.
Thank you.
All right. Thank you so much, everyone, for coming along tonight. That wraps up our evening. We are going to go to the conductor, as Alex said, which is just out the door, straight in front of you on the left, to hang out a bit more. Please return these badges. Please put these back in the basket. And if you are in the middle here and you're sitting on one of the chairs, not the pink chairs, please help us move those back outside when you go out. Otherwise, I will see you again next month. Thank you very much.
Coming out or not? I'm coming out. All right. That's good.